In Veritasium's video, he explained rainbow formation. So here we did a simulation of actually how the ray optics will give the result and how it supports his explanation. So let's see how we do it. Hi everyone, I saw an interesting video, probably you must have seen also. So Veritasium uploaded a nice video on rainbows, and I found this really interesting, specifically that part where he's actually showing from some experiment regarding how light actually travels on a droplet, an idealized droplet, that is a sphere, and how light is reflected and refracted on the surface as well as inside the solid sphere. So I thought maybe we can actually do the simulation and actually show you how it looks. So rainbows are actually very spectacular, and it's really nice that this video actually explained almost like most of the things that actually happening in rainbow. So I tried to model it, and let me show what I did to model the simulation, and then I will show you the result. So just to explain, I just took a screenshot. So this is what we're trying to simulate. So we will actually draw a circle because we'll solve in 2D, and then we'll have a source, and then we'll shine light along, let's say, the x-axis, and then we will see how it is refracted. Some part will again get refracted, and rest of the part will get reflected back and then refracted, and then we'll also have some secondary reflections and then again refractions and so on that are not directly captured in this video. So let's see how we'll do that. So basically we'll have a circle, and then we'll have a source, and this is how the light will propagate. So just to explain how things are working, so let's say we have this circle. When a light shines on this surface, let's say, now we know from ray optics, if let's say this is the incident ray and this is the reflected ray, and we generally draw a normal that is perpendicular to the surface, and if this is, let's say, glass and this is air, it will get reflected towards the normal, right? So this is how it happens on the surface. So similarly, maybe if you draw the normal, some of the ray will get reflected, that you can see easily in the video, and some will get refracted. And then since this is a denser medium, again there will be total internal reflection, and some of it will again get refracted, and then here again we'll have refraction. Okay, and then if we calculate, we'll again see some part of it getting total internally reflected, and then maybe again there will be secondary refraction and so on. It depends on how many orders of reflection and diffraction we are trying to capture. Okay, so let's see how we actually model this. So at first we create a sphere, a circle, because we are doing in 2D, and then we have basically created a block that will act as a source, and we use the geometric optics to actually simulate the rays and its interaction with the glass, or basically the water drop. And then we have the mesh done, and we did a study of the ray tracing, and this is the result that we are getting. So you can see we have the reflection, refraction on all the surfaces, and you can see that a majority of the ray is having a particular direction, which is explained in Veritasium's video. So let's see the final result. Here you can see how the ray is actually traveling with time. In this case, we are actually moving the source along the y-axis and then plotting the result of reflection and refraction of the rays. And you will see that after a particular distance, you will see that the ray will not come below a particular threshold, and then it will again start moving upward. That is what Veritasium has shown in his video via the experiments. I hope you find this video interesting. Please do subscribe for more interesting videos like this. Thank you and have a nice day ahead.